This is the video for momentum and impulse because there are also momentum and collision plus impulse, both chemistry and physics. Now let's take first momentum and impulse in physics, then later on in chemistry, especially collision. When you say momentum, from the word moment, this is the moment of force. When you meet somebody along the street and you don't know there is a surprise pushing toward your back, for example, there is a momentum there. Because if you're going to control the linear momentum of the body, there is a tendency to fall, okay? Because the quantity there is how a mass moves along a straight path. It does not necessarily move in a vertical position, position because you are, for example, walking, standing, or you're waiting for something. Okay, that is linear momentum. A force can change the linear momentum of a mass. The bigger the mass, the slower the momentum. But it is the smaller the mass, the faster the momentum. If you hit a hacker puck with a stick, the puck will move forward and there is a linear momentum associated. If no force attacking the puck, it keeps moving in the same path with the same velocity forever or until it turns out of, for example, ice. The linear momentum stays the same. Momentum and impulse arise from Newton's laws of motion. If you go back to the second law of motion, for example, constant acceleration is moving along a straight path. Remember, force is equal to the product of mass and acceleration. Now, how will you get the momentum there? The momentum is technically distinguished between how fast the body moves in a particular moment. Okay? So that is the second law of motion. The momentum, the momentum of an object is a measure of how hard it is to stop a moving object. And it depends on the object's velocity and mass, which are directly proportional to each other. That's why if you try to stop or to discount the moving vehicles, you cannot easily do that as long as there is a velocity there in motion, plus the body of that object is still in motion, accelerated, I mean, the momentum does not stop immediately. So, velocity includes the direction where the object is moving. The momentum is also in the same direction of the velocity. However, if there will be a zero velocity, then the momentum becomes zero because it depends on the mass of the object. Now, when you catch an object that is, for example, ball, and try to move, of time will change its momentum. According to the second law of motion, unbalanced force always accelerates an object, accelerates the body. So if you catch the ball, for example, on the air, because it is what? Throwing away because of the heat from the bat, what will happen if you don't catch it properly, for example? There is a motion going down. And that motion going down is the moment when the object does not control using your palm. So in other words, if the force acts opposite the object's motion, it slows down. Okay? But if a force acts in the same direction as the motions of the object, then the force speeds objects up. Correct? You but hit the ball according to the force exerted, then the object moves up or speeds up because of the motion that it goes up. Okay? And if the velocity of the object is changed, then the momentum of the object is changed. Okay? Now, the conservation of momentum states that the net momentum of the isolated system cannot be changed. A particle or object, a particle substitute a system. Let's go to collision because it is also associated momentum and impulse. Which momentum is transferred from one body to another with no change in the total momentum of the system. So there are conditions wherein collision is a measurement of transferring the momentum from one body to another. Perfectly elastic collision, kinetic energy is conserved, and the velocity of approach is equal to the velocity of separation. In other words, if you hit the ball and it is separated from that hitting after hitting the ball and it goes up because of the momentum, the velocity again, there is what you call equal velocity to the velocity of the separation. Separation before hitting the ball is equal to separation of the velocity there once the ball is flown. Okay. Now, another example is if you hit the ball on top of the table, you hit that, and there is a transferring of the momentum. If it collides from each other, there is a collision. So before collision, the first was moving toward the direction of the stationary ball, for example. After interaction, the first ball stopped and its momentum has completely been transferred to the second pole. Okay? That is transferring of force and acceleration because it depends on the mass. The bigger the mass of the object, is slower the body moves. The smaller the mass of the object, the faster the velocity of the body moves. Because in terms of acceleration also, because there is increase in speed, for example. Okay, that's all in physics, and good afternoon to everyone. We will see you again for the next video with regard to collision in chemistry. Okay, bye.